Welcome to this video on fractions, maths made easy. Now fractions can be thought of as part of a whole. So usually we talk about circles or a pizza because pizzas are cut into slices and things. So if we have a circle and we divide it exactly in the middle, it has to be exactly, then this part is a half and this part is a half, and both parts together make a whole. The way we write fractions, a half is written 1 over 2, the top being the numerator and the bottom is called the denominator. Let's look at a circle again. So if we divide it into halves, two halves, and then we divide the halves exactly into half again, then these become a quarter. Each one is a quarter. So if we shade two of those quarters, which is 2 quarters, this 2 can represent the number of parts that we're interested in, this 1 and 2. So this is the number of parts shadowed or shaded, and then this part, the denominator, is the number of equal parts the whole circle is divided into. So this is the number of parts the whole divided into. And we represent this as 2 over 4. Now the 2 over 4, or 2 quarters, it can be this line can be thought of as a division symbol as well, and if we do that, so that would be 2 divided by 4 equals, and if we do that quickly, so 2 divided by 4, so that won't go, and 2 divided is 0.5, and 0.5 is a half, so these 2 quarters circled equal a half. Another important point to bear in mind when we're considering fractions is that it doesn't have to necessarily be circles, it can be any shape. So say we had pictorially representing fractions a rectangle. If we divide the rectangle into 3 equal parts, so I'm just doing this by eye, but say those 3 parts are equal, each part represents a third. So if I represent the shaded part, would be 1/3 shaded. Similarly, if I did that again, so that's the same rectangle, and I divided it into 3 again, so that was a third. If I divide the 1/3 into 2, that was the shaded part originally here, and then I shade a half of a third, that would be 1/6 shaded. Okay. So when we're adding fractions, we can, if we add a third to a third, it's quite easy to see what's happening. It's going we're adding this part to this part. So this is 1/3 and this is 1/3. And as you can see pictorially represented there, it's 2/3. So when we have something with the denominator that's the same in an addition, it's quite easy to do. We just add the two together and we add the numerators and leave the denominator as it is. So 1/3 plus 1/3, 2/3. In this one, it's quite hard to see what's going on. So if we're adding 1/6 to 1/3, it's quite hard to see what we're doing. However, if we divide another third into 6, so that this is the 1/6, this is the 1/3. So the 1/3 we know is a 1/6 and a 6 together. Yeah. So this becomes 2/6. So it's like 1/6 plus 2/6, and that is 3/6. This is a very important concept in addition of fractions. We try and make the denominator the same, and then it's quite easy to add the fractions up because they're both the same size. The denominators are the same, and the little pieces, the 2/6 and the 1/6, are the same size, so we can add two little 6, so it's two of these, which are making a third, and we're adding 1/6 equals 3/6. Another important concept is the concept of a whole. So what is a whole or an integer? When we're talking about fractions, a whole number is the same numerator and the same denominator, and when we have that, that equals 1. So whenever we multiply anything by 1, whether it be a fraction or any sum, say 3 times 1, it remains the same, it remains 3. Similarly, if we multiply 2/3 by 1, which we said here was 3/3, we get 6/9, and this 6/9 and 2/3 are equivalent because we've multiplied it by 1. Another important concept when considering mixed numbers, say two whole ones and a third, and we want to convert that into an improper fraction, how we do that is we consider the 2 as being that, say 3 lots of 1/3, and that 3 lots of 1/3. And how we convert to an improper fraction is we multiply the denominator by the whole number, so that's 2 times 3, and then we add to that the numerator. So it becomes 6 plus 1, and it would be all over the denominator. So 2 1/3 becomes 7 over 3. A proper fraction is a fraction where the numerator is less than the denominator. For example, 4/6 or 12/18. In both these examples, the numerator is smaller than the denominator, and it's a proper fraction. Usually we try to make fractions into proper fractions by either making them into mixed fractions and giving that as an answer, or reducing to the lowest term and giving that as an answer. What do we mean by improper fraction then? So the improper fraction is the reverse of a proper, and that's where the numerator is bigger than the denominator. And an example, say 12/5 or 6/4. We try not to give answers as improper fractions to questions on fractions. We always try to give them as proper fractions or mixed fractions. So what do we mean by a mixed fraction? A mixed fraction has the form of an integer or a number, and also plus a fraction. So for example, 1 2/3 or 2 2/5. Both those are mixed fractions. We try not to give there is a way of making a mixed fraction into an improper fraction. Sometimes we need to do that for certain calculations like division, multiplication and subtraction of fractions. When they are mixed fractions, we need to make them into an improper fraction. So how we make them into improper fractions is when we have a mixed fraction with an integer and a fraction, we take the denominator and multiply it by the whole number or the integer. So that's 3 times 1. And then we add that to the numerator. So that's plus 2, and then all that over the denominator, 3. So that becomes 3 add 2, 5 over 3. What do we mean by equivalent fractions? An equivalent fraction is obtained when we multiply a fraction, both the denominator and the numerator, by the same number. For example, if we have 4/5 and multiply by 3/3, we get 12/15. In this example, the 4/5 and 12/15 are equivalent. Multiplying by the 3/3 is like multiplying by 1. So the magnitude of the fraction stays the same. Lowest terms. When we're reducing to lowest terms, we do. So when we're talking, so what do we mean by reducing to the lowest term? Reducing to the lowest term is the opposite of what we did earlier, and we divide both the top and the bottom by the same number. So we divide the numerator and the denominator by the smallest number, or by a number that both can be divided by. So in this case, 16 over 96, we can divide the top by 4 and divide the bottom by 4, and we get 4 over 24. And this can be reduced further. We can divide again by 4 and the bottom by 4, and we get 1 over 6. And that is 16 over 96 reduced to lowest term. Now when we are adding and subtracting fractions, the most important thing to bear in mind is making the denominators the same in the fractions that we're adding together. If we visualize this with a little diagram, divided into thirds, and that's a third, and that's a third. So the denominators are the same, and when we're adding them together, 1/3 plus 1/3, we get 2/3. The important thing also is that when we're adding, the denominators remain the same throughout. So the answer in the denominator is the same as the answer in the addition that we're carrying out of the fractions. So, adding and subtracting, if we make the denominators the same, or if they're the same to begin with, it's very easy. Now what if the denominators are not the same? So for example, 1 over 4 plus 1 over 3. So the denominators are not the same, so what can we do here? Well, we can make them into equivalent fractions where the denominators are the same. So 1/4, we multiply that by 3 over 3, and we get 3 over 12. 1/3, we multiply that by 4 over 4, and we get 4 over 12. So this is equivalent to this, and this is equivalent to this. But notice how we've made both the denominators now into 12. So we can write that becomes 3 over 12 plus 4 over 12 equals 7 over 12. So how can we make the denominators the same? The easy way is to look for what's called the lowest common multiple. So in this case, say we look at 4, we go across and through the multiplication for 4, and we see what multiplied by 4, what multiple can we get that is also a multiple of 3. So if we go 1 times 4 is 4, is that a multiple of 3? No. 2 times 4, is that a multiple of 3? No. 3 times 4, 12, is that a multiple of 3? Yes, it is. So we use the 12 as the denominator. So write that down first. Then for our original addition problem, we say how many 4s go into 12? 3, multiply the 3 times the 1, and we get 3. How many 3's go into 12? 4. So multiply 4 by the top, and we get 4. Now add them together. 4 12s, add 3 12s, 7 over 12. Let's look at that for another sum, another addition. 5 9s plus 1 over 6 equals. So we're looking for multiples of 9, the lowest common multiple of 9 that is also a multiple of 6. Go through the 9 multiplication table. 1 times 9, nope, that's not a multiple of 6. 2 times 9, 18. 6, yes, 3 times 6 is 18, so that can use that as a lowest common multiple. Put the 18 on the bottom as the denominator. How many 9s go into 18? 2. 2 times 5, 10. How many 6's go into 18? 3. 3 times 6 is 18. Do the same to the numerator. 3 times 1 is 3. Now add them together. 3 18s plus 10 18, 13 over 18. Now when we're subtracting fractions, that's also very similar to addition. The process is anyway. We try to make the denominators the same and then carry out the subtraction. So for example, if we're already given a subtraction where the denominators are the same, it's very easy to do. 3/5 minus 2/5 is 1/5. Now if the denominators are not the same, for example, a half minus 1/3, what can we do? We go through, as we did in addition, find the lowest common multiple of 3, which is also a multiple of 2. 3 times 1 is 3, is that a multiple of 2? No. 3 times 2 is 6, is that 6 a multiple of 2? Yes, it is. Write the 6 on the bottom as the denominator. Now we do to the top exactly what we did to the bottom to get a 6. So what do we do to the 2 to get a 6? Multiply by 3. So multiply the top by 3, get 3. What did we do to the 3 to get a 6? We multiply by 2. So multiply the top by 2, we get a 2. Now we carry out the subtraction. 3 minus 2 is 1, and the answer is 1/6. Let's do another one. 3/4 minus 1 over 16 equals. Choose the larger number and go through multiples, see which is a multiple of 4. 16 times 1, is that a multiple of 4? Yes, it is. So we can write the 16 on the bottom. What do we do to the 4 to make a 16? Multiply by 4. So multiply the 3 by 4 and we get 12. 16, that was just 1. So multiply 1 by 1, remains 1. 12 minus 1 is 11. And the denominator in addition and subtraction remains the same. So 11 over 16. So let's have a look at the denominator. We can just multiply across. So what I mean by that is, say we have a half times 2/5, 2 over 5. We multiply the 1 by the 2, and multiply the 2 by the 5, and then we get 2 over 10. If we have a whole number, 5, The 5 can be treated as 5 over 1. Say we were multiplying by a half, 5 by 10. That becomes 5 times a half. Multiply across, 5 times 1 is 5. 2 times 1 is 2. An improper fraction, we want to make that into a proper fraction. 2 into 5 goes twice. Remainder 1, 2.5. Sometimes if we have larger numbers or even smaller numbers, it's easier to make the fractions smaller to multiply them together. Let's have a look for that. So for example, in this top example we had a half multiplied by 2/5. So we look that way and that way in the multiplication. 2 cancels out the 2. 1. And now we multiply across. 1 times 1 is 1. 5 times 1 is 5. The answer is 1/5. This answer that we got earlier can also be reduced to 1/5 if we divide both the top and the bottom by 2. We get 1 over 5. Is similar to multiplying fractions in that we don't need the denominator to be the same, but there's a little twist which we'll go through. So say we had a half divided by 5. The 5 can be treated as 5 over 1. Now what we do to do a division is we get the reciprocal of what we're dividing by and then we multiply. So this then becomes a half divided by 1, and then we multiply. So it's a half times 1 over 5, which becomes 1 over 10. So reciprocal, the product of a number and its reciprocal equals 1. So for example, the reciprocal of 4 is 1 over 4, and the reciprocal of 2/3 is 3 over 2. Similarly, the reciprocal of 1/4 would be 4, and the reciprocal of 3 over 2 would be 2/3. We simply flip the numbers, putting the bottom one on the top and putting the top one on the bottom. That's the reciprocal. So when we're dividing, we actually change that to we multiply by the reciprocal of the fraction we're dividing by. So let's have a look at that again. So if we had 6 over 12 divided by 12 over 33, we get the reciprocal of the second fraction, the fraction that we're dividing by. So that becomes 33 over 12, and we multiply it by 6 over 12, and then we just multiply across, and that would give us our operations on mixed fractions. There are various techniques that we can use. Well, the techniques that I'm going to show you here work for all mixed fractions. When we're adding mixed fractions, what we do is first of all we add the integers or the whole numbers. So for example, 5 and 3/15 plus 2 and 1/15. First of all we add the whole numbers, so that's 5 add 2 equals 7. Then we add the two fractions. The denominators are the same, so we can add them directly. So that becomes 3/15 and 1/15 is 4/15. And then we combine the two, and that equals 7 and 4/15. That is the answer. Now, in the case where the denominators are different, for example, in 5½ plus 2 and 2/3. First of all, we add the integers, so that's 5 add 2 equals 7. Then we deal with the fractions, and we make the denominators the same by looking for a lowest common multiple. So look at the 3, and go through the 3 times table. Lowest common multiple, if we go 3 times 1, is that a multiple of 2? No. 3 times 2, 6. Is that a multiple of 2? Yes. So we put 6 plus 6. What did we do to the 2 to make 6 multiplied by 3? Multiply the top by 3. What did we do to the 3 to make 6 multiplied by 2? So multiply the top by 2. And then add the fractions, and that gives you 7/6, which is an improper fraction. So we make that into a proper fraction, 1 and 1/6. And now don't forget these integers that you added together. Add that, and that makes 8 and 1/6. When subtracting mixed fractions, we don't take away the integers. What we do for subtracting, multiplication and division is we make the fractions into improper fractions and then carry out the operation on them. So if we have 3¼ minus 1 and 2/3, so make it into an improper fraction. We have 4 times 3 is 12 plus 1 13 over 4 minus 3 times 1 is 3 plus 2 is 5, so that makes that 5/3. Now remember, when we're subtracting we need the denominators to be the same, so let's use the lowest common multiple example again, and then do the division. So we go through the 4 times table. 4 times 1 is 4, is that a multiple of 3? No. 4 times 2, multiple of 3? No. 4 times 3, 12, is that a multiple of 3? Yes. Put the 12s on the denominator. What do we do to the 4 to make a 12 multiplied by 3? So multiply the top by 3, that makes 39. What did we do to the 3 to make a 12 multiplied by 4? So multiply the top by 4, so 4 times 5, 20. Now subtract 39 minus 20 is 19, and the denominator remains the same. So that's an improper fraction, so we must give the answer as a proper fraction. How many 12 into 19? 1. Remainder 7 over 12, and that is the answer. Again, we convert the fractions into improper fractions and then carry out the operation. For example, if we have 2 and 2/5 multiplied by 1 and 6 over 24. So make that into an improper fraction. 5 times 2 is 10, 10 plus 2 is 12 over 5 times 24 times 1 is 24, plus 6 is 30. Now, is there any cross cancellation that we can do to make this multiplication easier? So let's have a look. 5 and 30, 5 will go into 5 once, 5 into 30 goes 6, 12 into 24, yeah, we can do that. 12 into 12 goes 1, 12 and 2. Now we multiply across. 1 times 6 is 6, and 1 times 2 is 2. So that's an improper fraction. How many 2's go into 6? 3. No leftovers, no remainders, so the answer is 3. Dividing mixed fractions, again, we do the same as multiplication, make it into an improper fraction, then carry out the operation. So 4 times 2 over 12 divided by 1 and 4 over 56. Make it into an improper fraction. 12 times 4, 48, plus 2, 50. (56 times 1, 56 plus that 4 gives you 60. Now remember, when we're dividing, we get the reciprocal of the number we're dividing by and multiply. So that's 50 over 12. Is there anything that we can do to make it simpler? Is there any numbers that go both into 12 and 56? Yes. We can divide that by 2, gives us a 6. Divide that by 2 gives us an 18. 50 divided by 10 gives us a 5. And similarly, divide the 60 by 10 gives us a 6. 5 times 18 is 90. And 6 times 6, 36. So that's an improper fraction. And when we convert into a proper fraction, we get 2.5. In mixed fractions, say we have 1 and 2/8. So what we do is multiply the 1 by the 8 and add it to 2. So 8 multiplied by 1 and add to 8 plus 2 is 10 over 8. Or the other way to think about it is, what was the whole one? The whole one was 8 over 8, because it's linked to this denominator. And then we're going to add to that the 2 over 8. So this was the 1, and this is the 2 over 8, and when we add them together we get 10 over 8. When we're converting into a decimal, we think of the fractions line between the two numbers as a division. So this 4/5 becomes 4 divided by 5, and if we do that as a division, 4 into 5, 0, 5 into 48. So the answer is 0.8. When we're converting when we're converting a fraction into a percentage, we simply get the decimal and multiply by 100. So again, like if we use 4/5, we do the division, we get 0.8. and then we multiply it by 100 and we get 80%. When we're converting a decimal into a fraction, we simply divide by the next power of 10. So for example, if it's 0.75, it becomes 75 over 100, and when we do that division, when we convert that, we get 0.75, or if we divide both the top and the bottom by 25, it becomes 3/4. Say we were dividing by 0.25, that would be 25 over 100. We can divide both the top and the bottom by 25, and that would give us 1/4. When we divide 1 by 4, we get 0.25. I think this would be a good time to talk about recurring decimals. So if we have a recurring decimal, by that I mean something like 0.777, what we do is we let the 0.777 equal x and label that 1, and then we go to the next number where it's not recurring, so it would be, or where the recurring appears, so that would be 7.777, and we make that 10x. So we multiply this by 10, and then label that 2, and then what we do is we subtract 1 minus 2, so subtract this from this, and we get 7 equals 9x, and then x equals 7 over 9. Quite often in exam questions we're asked to compare fractions, and there are 4 ways that we can compare fractions. The first way is if we're given them and the denominators are the same, say 2/3 and 1/3, we can compare them directly. So obviously 2/3 is greater than 1/3. The second one is to make an equivalent fraction, to make them the denominators the same. So if we were given 2/3 and 3/4, we'll make that into an equivalent, so the 2/3 becomes 4 over 12, and the 3/4 becomes a 9 over 12. And we can see that the 9 over 12 is greater than the 4 over 12. The third way is to make all decimals, as I've shown earlier, and the third way is to make into percentages. Scientific notation. You have to remember that in scientific notation we're talking about one number and then a decimal point and then how many tens or how many thousands or 10 to the minus 2, 10 to the minus 5. So for example, in 6, that equals 6 because we've just got one number by itself. However, if we were given 65, we need to make that into just one number and a decimal point and then the 5, and that becomes, there we go,